Mineral and water abnormalities in diseased cells are a critical problem that should really be a part of any treatment protocol. This technology is specifically designed to impact ion motion of the mineral within the body fluids across the cell membranes. If you look at diseased cells, what you're going to find, you're typically going to see a problem with ion charge. For example, sodium, a lack of charge potential with sodium prevents the ions from properly binding to the protein channel. And if they don't bind and move through that channel, then that sodium is going to accumulate in the cell. If they don't bind, that also prevents potassium from binding on the other side of the channel or the other side of the membrane as well. So the movement or transport of these charged ions through their ion channels is basically responsible for creating the flow that drives the transport of several processes across the cell membrane. You'll probably remember from Biology 101 the sodium and potassium pump. And here's the interesting thing. A diseased cell, it's always going to lack balance in intracellular fluids unless water, sodium, and potassium are in a state of constant motion between the intracellular and the extracellular compartments. So the question is, why do these ions, and we're talking about sodium and potassium specifically, why do they have to be electrically charged? Because the channel itself relies on the flow of electrical currents through that membrane. In other words, the charge on the sodium or the charge on the potassium itself will influence the cell's ability to move substances in and out of the cell. So this technology is involved specifically with charging sodium and potassium. We're talking about optimal photon emission. Optimal photon emission from sodium is around 580 nanometers. From potassium, it's around 350 nanometers. However, in a diseased system, photon stimulation of these ions is impaired for several reasons. So how does the vacuum generator resolve this issue? The vacuum generator externally implies specific supplemental charges that restore the ion's ability to properly communicate, if you will, or emit the proper wavelengths at the binding site of the membrane channel. And if you've watched the video on erythrocyte permeability studies that we've done, then you can see how a technology like this can restore or at least improve active transport, talking about moving stuff in and out of the cell.